Okay, now we are going to begin our study of number systems, and the first thing we need to do in studying number systems is understand the one that we use every day, the decimal system. So we are going to first take a deep dive into the decimal system. Okay, now we're going to look at the decimal numbering system, and in this, even in the description here, the deci means 10. If you think of a decimeter as a tenth of a meter, that is where that prefix comes from. It has a value of 10, and we have 10 specific shapes that we can represent the 10 different values found within that set for that numbering system. These specific shapes are actually termed digits. So the base 10 numbering system has 10 digits associated with it, 0 through 9. Each shape is unique, so we can tell them apart from one another. And since there are 10 of them, we call this the base 10 numbering system. I'm going to put the 10 down here in red to make it stand out. And that's written in subscript, so it's a little bit smaller than the actual text when we write base, and when we actually write the number, we're actually going to put a 10 as subscript to identify it as a base 10 as well. So let's take an example and let's see how we actually come up with that value. So if I have a 1 and a 1, now normally when we look at a number, we just have these two digits next to one another. The stacking has a certain process that we have to come up with to determine the value of that number. So the positions that they're in is very, very important. In fact, this right here is a place in the number, and this right here is a place in a number. So that's going to be another term that we're going to talk about here, is a place. Okay? So we'll get into that in just a minute. But when we talk about a number like this, normally we just write the number. Technically, this is a 1, 1 in the base 10. Let me actually write it in red so it matches. Okay, that is base 10, 11. And I want to figure out what the value of that number is in that particular base. So, like I said, we have specific places, and we need to uniquely identify these places based on where they are in that stack of digits. Well, if we look at the number line that we learned from years ago, the number line starts at 0, and you can go to the left and it's negative, and go to the right it's positive. When we start counting, we start at 1, and then we go to 2, and we go to 3. Those are actually natural numbers. When we talk about integers, we actually start at 0, and we move to 1, and then we move to 2. Okay, those are whole numbers. So in this case, we're going to start identifying the position of our digits in this number with the number 0. So this is going to be the 0th position. Okay, this is going to be the first position. If I had more digits, I would just continue to increment. That would be the second position. It would be identified with the number 2, and the next position will be identified with the number 3. Okay. Now we need to figure out what are the weights of each one of these places. Okay. So I'm going to come down here and I'm going to write the word weight, because the place we identify with the 0, 1, 2, or 3, and we're going to give it a name once we figure out its weight. So if we take the base, our base 10, and we raise it to our place identifier, that power, we're going to find out what the weight is there. Okay? So I'm going to write 10 to the 0 there. I'm going to write 10 to the first here. 10 squared and 10 cubed next to that, because those are those place identifiers. And then we're just going to do the math. So any number raised to the 0th power is going to be 1. Okay, so that's going to become a weight of 1 there. Any number raised to the first power is going to be that number. So we're raising 10 to the first power. We're going to get that value there. Okay. 10 times 10, 10 squared is going to be 100. And 10 times 10 times 10 is going to be 1,000. Okay. So those are the individual weights of these places. Okay, so the weight can be calculated this way or just be identified that. So that's why we say the first digit to the right is the ones place, the next digit over is the tens place, the next is the hundreds, and the next is the thousands. Okay, if we want to actually figure out the value of an example, in this case, the 1, 1, I'm going to bring it over here. We know that this is the ones place and this is the tens place. We calculated that over there. As we bring this down, if we multiply these, we're going to get the actual individual value at each place. So in this case, 1 times 1 is 1. Now remember, I had 9 different digits that I could have selected in my example here. I just have 1 there now, but if it was 0, I would get a 0. If it was 9, I would get a 9. Okay, here the weight is 10, the tens place. Multiply that times 1, I get 10. And now all I have to do is add across, and I will get the actual value, which is 11. 1, 1 in base 10. Okay? So that's how we actually can take the base, the digits in the base, and calculate the individual weights and the ultimate value of that number. Okay, so next we're going to look at the binary number system. Okay, now we're going to look at the binary number system. This is going to be different from our decimal number system. It's kind of given away in its name. It starts with BI. If you think of bicentennial, biweekly, bicycle. Bicycle has 2 wheels as opposed to a tricycle which has 3 wheels. The BI stands for 2. Okay, so in this case, when we get to our unique shapes that identify the set and have a specific value, those digits are all we're going to have in this number set. Okay, so the digits in our binary number set are just a 0 and a 1. Those 2 shapes is what is going to actually determine that value. Okay, now each one of those has, when we have a number, is going to have a place. So again, my example of 1 and 1, again in this position, we are going to label this the place with an identifier starting at the integer 0. Then we're going to move over to 1, again 2 and 3. So that hasn't changed since what we looked at in the decimal system. What is going to change now, when we had to figure out our weights, remember, weight is our term for the actual what weight that carries at that position. We're going to take our base, and this is, since binary is based on 2 shapes, it's going to be base 2. Okay? We only have 2 shapes in there. So here I am going to take 2 and I'm going to raise it to the 0th power. And here I'm going to take 2, I'm going to raise it to the 1st power. And then here, if I had values in those positions, I would square 2 and cube 2. Okay? So now you can see the weight is going to change. It's going to be different, and it's determined by the base. So 2 squared, 2 to the 0th power, any number to the 0th power is going to be 1. Okay, that's just a mathematical principle. Any number raised to the 1st power is going to be that number. So in this case, it'll be 2. The weight here will be 4. 2 squared, 2 times 2 is 4. And here, 2 cubed is going to be 8. Okay, so there are my individual weights for these different positions. So starting at this position identified with the 0, it's going to be the 1's place, but then identified with the 1. Remember in decimal that was the 10's place. Well, now it's the 2's place. And then on the second one for the 2 integer, that's the 3rd digit over, identified with the 2 is going to be the 4's place and the 8's place. Let's take our example number again. But now our example number, we're going to write a subscript 2 here to identify it as a binary number. Okay, I'm going to be consistent here and put my red. Okay. And now in this first place, we carry a weight of 1. Okay, so in that first place, I'll still have a 1 there. In the second place, now I'll have a 2. Remember, we multiply down. So 1 times 1, we're still going to get a 1. And then 1 times 2, we're going to get a 2. And our process is we add across. Okay? We add across, we're going to get 3. And that's going to be 3. That ultimate value is going to be 3 in decimal. So 11 in base 2 is going to equal 3 in base 10. Okay? Now we're going to have another video on converting back and forth so we can get some more practice on this. The main thing that I wanted you to understand in this video is the term of digits, the term of place, and that place's individual weights and how we derived those weights. The binary number system ports very well into computer systems because the binary number system only has the 2 digits. Those 2 digits can represent only 2 states. And if you think of a light bulb only has 2 states. It's either on or off. And that is actually the principle that computers run on. Ultimately, they run on machine language, and machine language is comprised of 1s and 0s. So if in my original example I just wrote 1, 1, like Forrest Gump said, life's like a box of chocolates, you never know what you're going to get. Well, if we don't actually denote this with this subscript here, we don't know what we're going to get until we actually literally say what subscript or what number system that we're in. So for base 2, we're going to write a subscript 2. For base 10, we're going to write a subscript 10, and that lets us know what we're actually going to get as a value when we're done. We'll see you in the next lesson. Thank you.